Good morning, everyone. And welcome back to our BIOCON-CO2 Final Symposium, and also welcome to the new participants that could be online today and joining us for the policy session, which will be the last session for our event that we have organized. Today we have as moderator, but also as a speaker, we have Despina Skolodimokuri. She's finishing her PhD in the National and Technical University of Athens in Greece, and she's also a technological transfer consultant and policy expert. So she's now going to give us a brief summary and the context on CCU and BIOCCU technologies, and also the opportunities and how the trends and the policy environment is now ongoing in Europe. So right now, Despina, you have the floor.
Thank you very much, Javier.
Thanks.
Good morning, everyone. Thank you for showing up here today. This is Despina Skoloudi, and I'll talk to you about sustainability evaluation of CCU and BioCCU technologies. A brief introduction of my position at the Technical University of Athens. I'm finishing my PhD at the Laboratory of Steam Boilers and Thermal Plants. Our main activities there involve the process modeling, thermoeconomic and techno-economic optimization of energy systems and industrial processes. And the last couple of years, we have been involved in sustainability evaluation of both energy production management and industrial process technologies. So our role in BIOCON-CO2 is mostly in work package 8, where we are the lead of sustainability assessment activities. So just for a short introduction on our today's subject. As we saw yesterday, we have a lot of international activities on combating climate change. The European climate law was upgraded at the late 2020 to account for 55% greenhouse gas emission decrease by 2030 in the Fit for 55 package. So it is now well recognized that not one silver bullet exists. We need a series of technologies and toolkits in order to achieve this ambitious target. The IPCC report is also mentioning in its latest update that we cannot achieve climate neutrality without removing carbon. So in order to remove this carbon, we also need to decarbonize our industry and power generation, but we also need to use technologies just like CCS and CCU. What's the difference? In short, CCS aims to permanently store CO2 and remove carbon permanently from the biosphere to refrain CO2 from re-entering the atmosphere. Whereas in CCU, we are trying to find ways to convert CO2 from our enemy into our ally by using it in our production and substituting this way fossil resources. So what's being performed until now? The main aspects of sustainability that we are concerned about in CCU technologies are how to achieve climate change mitigation, how to maximize this potential, what's the energy demand, what's the economic benefit that might arise from such a technology, perhaps how to combat other environmental issues, and of course, last but not least, the maturity of the technologies. But all those are always in line with the sustainability goals, the Sustainable Development Goals of the UN, of the United Nations, which were published in 2015, are always our major guide in this attempt. I'm sure you've heard of them. They cover all aspects of human society development, from fighting poverty, fighting hunger, promoting good health and well-being, up to climate action, sustainable production, consumption, sustainability in cities, protection of life above and beyond water, and forming partnerships all across the spectrum of human activities. So what's often neglected in our sustainability assessments in these technologies is the social part. We're always about the planet, we're always about the environmental, the traditional life cycle assessment, or carbon footprint analysis. All of those methodologies are there and have been there for decades. Of course, we're also very much concerned about the profit aspect. We need to make it profitable. We need to make all these technologies viable. But the least explored aspect is the social, the people part in this triple bottom line approach. So this is where legislation comes in. This is where social inclusion aspects come in. This is where the welfare, well-being of the people comes in. So what we did in the Biocon-CO2 project was first make a literature review of what's being performed up to this day in CCU-related projects and evaluations. We also studied how contemporary social impact assessment methodologies address these technologies, and we came up with a set of selected indicators, which you can see here in the blue boxes. And these are the most common indicators in such technologies. And we took these indicators and asked a number of stakeholders involved in CCS and CCU to validate their importance in this subject. So about the economic part, I can show you some recent data on operating or recently operated biological pilot and demonstration CCU plants. Of course, you see that most of them are not very large-scale plants. We have capacities of up to 4,000 tons per year. But these are validated technologies, and we're hoping for a capacity build-up to be coming up in the next couple of years for the thermochemical that is until now. For the biological CCU, you can see at the bottom two big demonstration plants. One is the Steelanol that we have the honor to be very close today in Ghent, Belgium. And the other one is the Electrokea, which was also mentioned yesterday. There's a methane conversion reactor of 10,000 liter capacity in Denmark. Now, how about scaling up the technology? This is a very complex issue. This graph here shows that we can go for greenfield biorefineries, but the capital expenditure that is very big. So, and looking for ways to reduce this expenditure, we're focusing on existing plants which can be repurposed or can be co-processed regarding some waste streams or co-products, and just focus on debottlenecking these procedures, and just by including as less complex as possible processing steps, we can reach the targeted carbon capture and conversion efficiency. So another aspect of The economic evaluation of CCU technologies is what price of CO2 we're using for our evaluation. You're all familiar with the ETS. We also talked about it yesterday. You can see a recent graph here on the right. But it's not just the ETS that drives the carbon capture cost. If we're planning to use CO2 that's being purchased, then we need to include CO2 market data, which are shown here on the left. In fact, the CO2 market, this is data got from Eurostat, from the Prodcom database. You can see that CO2 market is fluctuating in the last 10 years regarding both the volume sold and its value. Volume is in orange and the value is in blue, which is adjusted in 2020 euros. And you can see that in the last couple of years, the carbon dioxide price is pretty much stable compared to the previous 10 years. And it's, but still it's increasing every year. And it's reached 100 euros per ton. So we made a case study. I'm just showing some preliminary results here because our final results are not yet published. We're still refining the results. So I wanted to share with you a case study we did for mixed alcohol production. There was an evaluation of an upscaled plant that had a very big overall capacity. Almost 600,000 tons per year. And we managed to find this as a competitive scenario. You can see here that the cost drivers are the capital expenditure first, as we talked about it previously. And of course the hydrogen cost and the electricity cost, which is also a hot topic these days with power prices going up. But still, and our internal expert calculations have demonstrated that we have the potential in developing the technologies, and further developing the technologies studied in BIOCON-CO2 to create 20 billion euros of turnover. And of course, more than 4,000 jobs in the chemical industry and more than 25,000 indirect jobs and almost 1,700 construction jobs across Europe. So here you can see our reference values. You see that the electricity price is, well, not very high compared to today's prices. So these results will need to be certainly need to be refined. And about the expert survey, we targeted certain stakeholders from the CCUS European sector. We targeted them through the consortium and the Cooling the Earth mailing list. We formulated questionnaire for a questionnaire-based interview. We reached almost 90 experts in March and April, and we got 23 responses from 7 countries. You can see the age and gender distribution in the bottom. And what is important in evaluating the results of the survey is that the 61% of the experts participated in CCU R&I projects, but 35%, almost 35% did not. 35% were coming from the CCS sector. And regarding their background, these are mostly from research, mostly from public sector, and some from the private research activities. But we also included stakeholders from the energy industry, manufacturing, utilities, construction, and other private sector stakeholders. So here I've included some tables on the results. Here you can see how the relevance of the existing legislation is viewed compared to the evaluation of biological CCU products and value chains in the future. Of course, most of the stakeholders find the European Commission communication of sustainable carbon cycles as most important, and followed by the Circular Carbon Economy Index and tools, and of course the platform for accelerating the circular economy, the PACE platform, as it's known. And other standards are, of course, the EU Green Deal is a major legislative act that's viewed as of major relevance, and the Circular Economy Action Plan, as well as the Waste Framework Directive. So afterwards, we asked for the participants' opinion on the importance of the indicators we selected, the set of the 11 indicators I talked to you about previously. Of course, the indicator number 5, potential for combination with bio-based production processes and integrated biorefineries, was one of the most popular, as well as the functionality and efficiency compared to fossil-sourced and bio-based alternatives. But the most relevant, the most important indicator was the reduction of dependency on non-renewable resource imports, which was also one of the most pressing issues in yesterday's discussion. And afterwards, we asked their opinion on some statements regarding the future performance of CO2-based products. I'm not going to bore you with all of this analysis here. We can jump to the conclusions. So, of course, as we talked about, the economic performance greatly depends on the opportunities for lowering the capital expenditure and the energy costs. And integration with existing infrastructure must be attempted, but is always case-specific. And of course, one of the outcomes of the social survey was that carbon removals and increases in CO2 capture and conversion efficiency must be reported in detail first, and second, using the same framework in order to ensure comparability and consistency of the methods and the evaluation. And of course, the formation and the regular update of a toolkit or a knowledge transfer system, along with the formation and regular update of certification and labeling frameworks, is expected that will assist private firms in assessing their potential for implementing biological CCU processes. And the provision of incentives, both at national and EU level, is expected to be more beneficial when provided both to new greenfield CO2-based industries and for transforming existing infrastructure and conventional industries. So that's all for now from my side. Thank you very much. I don't know if we have any questions.
Yes. Any question from the public? No? Maybe it's too loud, maybe. Okay. And from the online participants, we don't have also any questions. So, maybe. Yes, Hannah? Of course.
Hi, Despina. I have a question because you show the expert survey did you do other surveys with the general public or some kind of events that you know of in the project?
No, we didn't do a general public or general customer experience survey because our aim was that since the Biocon project is still at a low TRL level, we didn't have a certain final product that we could communicate with the end customers. Yes. So we evaluated that at this point of maturity, maybe a market perception survey would be more beneficial.
Okay, thank you.
Thank you very much.
Okay, any other questions so far? So, well, Despina, you're also the next speaker, right? So,
let me change my hat.
All the floor is yours.
Thank you. Just so, hello again. And let me get into presenter mode. Okay. Yeah. So, no. We have a trouble with the slides here. Excuse me for this. We were... Okay. So, excuse me for the slight interruption. So, now it's Despina Magiriskoulou again, here to continue with the more established subject of environmental assessment of CCU and bio-CCU technologies. So, you know me now, so let's move on to the introduction. As we said, we're aiming for an integrated sustainability assessment in order to provide enough proof that our technologies are capable of assisting in the efforts to keep global warming below the 2 Celsius threshold, as shown in the IPCC graph. Here on our left, we can see that the models without carbon removal are not beneficial enough in restraining global warming below 2 degrees Celsius. So here we have a big table from a recent study that shows the potential in selected European countries for coupling with EU large CO2 point sources. You can see on the left columns the total annual CO2 production from large point sources and an estimation of CCU fuel production in 2030 and in 2040. So we can see that according to the CO2 reduction, the theoretical maximum fuel production also drops between 2030 and 2040. But this is why a mixture of technologies is required in order to transform our industrial production system. So here we see a number of high TRL CCU projects in Europe. We also saw the Iceland plant in the previous slideshow, the 4,000 tons of methanol per year. And we also see more ambitious projects, such as the C2 fuel, which is aiming to produce 2.4 million tons of formic acid per year. I'm not sure if they've achieved this target yet. Perhaps if anyone in the audience has an update on this, maybe they can update us. But in any case, some general facts on CCU, on the environmental assessment. It has been shown that CCU technologies can utilize up to 8 gigatons of CO2 per year by 2050. And The estimated potential for scale-up varies from 1 to 4.2 gigatons per year. And of course, our aim for CO2 capture is not only large point sources, but also direct air capture, which is a bit more troublesome at this point, since we need to process large volumes of ambient air with low concentrations of CO2. But in any case, the costs for direct capture have been dropping in the past years, and even capture costs lower than $100 per ton have been reported in the last year. And of course, according to Carlson et al., CCU technologies can reduce GHG emissions by 3.5 gigatons of CO2 equivalents in 2030. And CCU technologies based on carbon mineralization can reduce climate impacts over the entire life cycle of the processes based on current state-of-the-art and current energy mixes, which means that we can save up to 1 gigaton of emissions per year on the cement industry. So a couple of words about LCA, life cycle assessment. I'm sure you've all heard about it. We need to just explain some terms over here. LCA is a methodology we use for identifying, evaluating, and minimizing environmental impacts involved in the entire life cycle of a product or a process. If you see on the right, we are starting with the raw materials extraction. We're transforming the raw materials, transporting them, using our products. We're doing waste management scenarios. And of course, in a circular economy, we are using our wastes as raw materials again and feeding them back into the industrial production schemes. So the LCA framework comprises of 4 stages. We first have the goal and scope definition, the inventory analysis, the impact assessment stage, and of course the interpretation. And as you might have seen, it's a circular process, which means that all the conclusions from each step can feed back into the previous steps, and the circle can go all over again until we find an optimized solution. Now, a big part of conducting an LCA study is setting the correct system boundaries. In CCU studies, these are usually gate-to-gate for the techno-economic analysis, which means that we are making an analysis that's from a plant gate to the waste management gate. That's why it's a gate-to-gate study. For the LCA, we usually go for a cradle-to-gate, which covers the production, the extraction of the raw materials and the production of the final product, but it skips the waste management activities. And the most comprehensive, the most wide category is the cradle to grave, which can be conducted both for the environmental assessment and for the economic assessment. Here we try to measure the impact of all production, consumption, and waste management activities. On the right, you can see a typical scheme of system boundaries for CCU technologies. You can see 2 ways of having synthesized a fossil-based process and comparing it with a CO2-based process. Of course, the hydrogen is not always a co-product of CCU processes. This was just the case for the specific study. And of course, here they're using natural gas as an energy source that's being replaced on the upper case by hydrogen. Now, when we're talking about a value chain in CCU, it's very complex because this can encapsulate pretty much all the industrial processes from extractive to equipment manufacturing to high-emitting industrial producers such as steel manufacturing, cement, and of course the power sector. And of course, in the lower right, you can see the production of materials and fuels, which is our main product target. And there are so many industries that are based on these sources. Basically, all industrial production is based on the energy sector, so we can say that CCU is the leader for the transformation of the entire production activities. And now for some results from the Biocon CO2 project. Here we can see the system boundaries. We have included the 3 major steps of the gas pretreatment, the reactor operation, and the product purification for all our studied scenarios. Of course, the hydrogen is considered to be produced by PEM electrolysis. This is also included as a background process, which means that we are not considering it directly as part of the BIOCON-CO2 process flow diagram, but of course it's an important contributor to the system since we are dependent on hydrogen, and in some cases, such as the aerobic fermentation, we are also dependent on the oxygen produced by the system here. So some alternative scenarios we formulated are shown here. We evaluated a scenario where no gas cleaning is required, so we skipped the gas scrubbers. We've varied the electricity source. We had on-site hydrogen production, which means that we moved the electrolyzers from the background to the foreground processes in our system, and again varied the electricity source used for the electrolysis. We varied the waste gas supply both with pressure swing adsorption treated blast furnace gas and with the cleaned coke oven gas. We also varied the reactor pressure, and we run an alternative scenario of less energy intensive downstream processing. So in the bottom you can see some of the global warming potential results. The red line is the baseline butanol carbon footprint as a global market average. As we see here, scenario 1.1 was the base scenario, the reference scenario. As you can see, we're not doing much of an improvement in our reference scenario. We're barely below the current market average. But when altering the energy source, we can see major improvements, with the best improvement being for hydropower. And here you can see the comparative global warming impacts of regarding the conversion of carbon to the final product. We see that it's not a linear correlation here. We see that we have the minimum, the lower global warming for 50% conversion, whereas if if we go for a higher CO2 conversion, then the global warming rises, because we have accounted for larger infrastructure, both for the bioreactor and for the downstream product purification, which means we have higher energy demands and higher construction impacts of the equipment. We need to remember that we are talking about very large amounts of steel, which is also it's stainless steel, so the impacts are great in this case. And what was also remarkable was that the reactor overpressure was also not exactly linear. It was not that much of a straight line. If we see that in rising the overpressure, we saw that there's a plateau between around 3 and 5 bar G of overpressure. And above that, the global warming potential starts to rise significantly. So this indicates that, of course, we always need to remember when evaluating these results that these are based on a preliminary process design. The TRL is still very low. We need to continue with the detailed engineering and the detailed process design in order to refine these results further and see exactly how the trends are going in these correlations. But even at this low level of technological maturity, we can see that perhaps just the optimization of one parameter might not be enough for evaluating the overall process. So we need to find the multi-criteria optimal window of operation for the entire system. So what's shown here is the breakdown of impact assessment between all stages of the life cycle. We can see that in blue, the downstream separation of the alcohols. We can see that this is a large part of the global warming impact, because in the standard scenario we are using distillation. So distillation columns are very well known to be energy intensive. So this accounts for around more than 40% of the entire global warming potential of the entire system, with the rest being due to the bioreactor construction and slightly less from the bioreactor operation. Now, the impact assessment was performed using the recipe 2016 midpoint method, which has 16 indicators. The last one is the water consumption on the right. And of course, the major contributor to water consumption is the bioreactor operation stage in red. And here we can see the again, all the 16 indicators on the left, and for a number of varied scenarios in varying the energy source, for 50% carbon conversion. And we are also including the butanol market average in orange as a reference scenario. So here we see that the renewables-based scenarios perform much better than the market average in terms of global warming, and also in terms of water consumption. Another approach is the endpoint version of the recipe method, which is shown in the bottom right So from the 16 indicators, we go up all the way to 3 major indicator groups. And we see that we have, again, a number of scenarios with the butanol market production in pink this time. And we see that all the studied systems perform worse in terms of human health impacts than current butanol production. But a number of alternative scenarios perform better in terms of ecosystem impacts, and most of them perform better than current butanol in terms of resource protection. So just to wrap up, we see that biological CCU offers certain advantages compared to current chemical CCU installations. Of course, there's significant potential for further process development. The carbon emission impacts and the global greenhouse gas impacts are highly dependent on the electricity and, in general, the energy used. We need to continue researching on process design and optimization in order to ensure the improved environmental performance of the future upscaled applications. And of course, we need to focus on advancing the productivity and process intensification. So that's all for now. Thank you very much. I don't know if there are any questions. Yeah, please.
Thank you. Just
Yeah, that has to do with the mining activities mostly involved in the construction of both the steel for the equipment and, of course, the renewables. Don't forget that the renewables are also dependent on resource extraction. Let's say the PV panels need silicon, or the wind turbines also need a lot of steel and copper, and of course cement for the grounding. So they're renewable, but they're not completely innocent. We're still developing these technologies as well. We need to make them more environmental friendly, and of course the major aspect of PV and wind is that they're not yet entirely recyclable. So we have major issues in taking the waste from demolition from the wind turbine foundings and all this cement and copper, and even their turbine blades. Most of them are composite materials and cannot be totally recycled, and the materials cannot be entirely reclaimed. This is a major aspect of what we're trying to focus on in promoting the sustainability of such energy technologies.
yeah, I understand it, but for me, it would sound logic, okay, that this would have an environmental impact, okay, waste disposal, recycling, and that. But why is it the influence on human health negative? Because you saw that you had more, in general, or at least for some scenarios, more positive prospects for resources and the environment, but not on health. So, but health would be on health indicators of humans. So that
health is the health impacts are mostly from the ozone formation, from radiation, and from if we see back at here. It's most of the human health impacts are due to it's the HCT the human carcinogenic toxicity and the HNCT human non-carcinogenic toxicity. Those toxic materials come from, again, the separation of the minerals used for the construction of all the foreground and background equipment. And there's also a large potential for eutrophication. The FEU indicator is a freshwater eutrophication, and MEU is marine eutrophication. These are from compounds such as phosphorus and nitrogen compounds released in the biosphere, which also comes all the way through the food chain, comes to the final consumer. And of course, we also have the particulate matter formation, FPMF, which is also much worse than current butanol production for all scenarios.
Okay.
Which is also, again, by combustion during industrial production. So it's a series of indicators that, okay, each one of them is not directly transformed into human carcinogenesis or human disease, but all of them are, all of them combined do affect human consumption and production.
It sounds worrying also for social acceptance.
Yep, that's
Okay.
another aspect that we need to work on.
Okay.
Thank you, Andreas. Thank you, Despina. Any other questions? We still have 10 minutes for this session, so anything you will be able to discuss with Despina. Okay, I just want to check. No, there is also no questions from the public, so, well, anyway, we can leave it here for the coffee break. We'll be back actually at 11, so we have a short, quite a break. So when we come back, we'll just start the panel discussion. So thank you very much for the attendance.
Thank you. Now we're starting the panel discussion session. We have 3 panelists with us for this discussion. We have Dr. Mar Perez Fortes online. She is a tenure track assistant professor at the Faculty of Technology, Policy and Management of TU Delft. She's a chemical engineer in background, and she has done her postdoc in the United States of America, and she has also worked with the Joint Research Center in the Netherlands. And she focuses on the techno-economic assessment of emerging technologies, including bioenergy, CO2 capture and use, and electrochemical devices. We also have with us Dr. Joanna Ziganou. She is the Director of Research at the National Center for Social Research in Greece, and her expertise is in social sciences. She's been involved in a number of European and national research project management and coordination, and she focuses on the socioeconomic impacts of policies in the fields of energy and industry, and focusing on the spectrum of the current climate crisis. And last but not least, we have Dr. Bertis Vanderburgh, a molecular geneticist in background with a PhD in protein engineering and postdoc in vaccine development at the University of Groningen. And he's now a Chief Scientific Officer at IM and Bioengineering, a company located in Groningen, the Netherlands, with expertise in the application of microorganisms and enzymes. And he has also worked as an evaluator of European research projects and proposals. So welcome everyone. Thank you for joining us. And Just to start the discussion, just want to make sure that you can all hear us first.
Yes.
Thank you, Mar. I don't know if you want to add something about yourself, or welcome. Oh, I see we. Excuse me.
Yes, thank you for the introduction. Everything is all right. Yes.
Thank you. And we also have Dr. Ziganou with us. Joanna, can you hear us?
Hello, everybody. Can you hear me?
Perfect. Thank you.
Okay.
I don't know if you have any comments.
Some connection problems, but thankfully everything seems to work fine at the moment. Nice to meet you all remotely.
Perfect.
After the introduction.
Thank you. And how about you, Bertis?
I think you were quite complete for the moment, yeah.
Thank you. Thank you very much.
Yeah.
So, it's time to start with the questions. I think, first of all, I'd like to ask all of you which would be the most critical parts of the developing value chains for CCU-sourced chemicals, and what could be the potential benefits, what would change in a positive or a negative way in the case of biological CCU-sourced chemicals. I think I would start with you, Bertis.
Yes, okay. Well, I think that the most critical part will be in the whole value chain, the development of very efficient processes. And at this moment, many processes are under study, many different steps are being developed, but they have to become more efficient and better fine-tuned to one another, I think. And what I've seen, and that's also something from my background, I've looked especially at the use of enzymes and microorganisms, and I think those are very valuable tools to be used in the whole chain. But the enzymes are to some extent lacking the suitable stability, so they're not perfectly suited for the tasks and the environments where they have to be applied. And when you look at the fermentation processes, they also have to become more robust and more resistant towards the condition applied. So I think there is quite a challenge to develop that and to improve that. And further downstream, also the downstream processing should get some more attention, because you want to end up finally with highly purified products which can be used for different applications, especially when you're looking for food or other maybe pharmaceutical applications of the product, then very highly purified products are needed. And I think there's also quite some work to be done.
That's for sure. Thank you.
Yeah.
And how about you, Mar?
Yes, so I would say I completely agree with what Bertis has mentioned. To act like, in the sense like, okay, if we zoom out a bit more, so we have different indeed stakeholders, right, that are involved in the supply chain. So in general, for CC processes, let's say we have the stakeholders that provide the CO2, we have the stakeholders that provide the electricity, and we have also stakeholders that may use, right, the product that we synthesize from in the CO2 utilization process. So looking at the, let's say, the perspective of each one of these stakeholders, each one of them has its own interest, its own scale particularly, right? So then I would say that also thinking about what Bertis reported, like how in fact the plant look like, also the stakeholders needs. I believe one critical part to develop this value chain is really to understand what is a relevant scale for implementation. And I believe each one of the contexts maybe will provide different, let's say, circumstances and different factors that will allow us to think, of course, that for every particular situation, different scale make sense. That would be one factor. Another factor is also linked with development, so it's cost. Indeed, we are talking about low TRL technologies, electrochemical, biochemical technologies are low TRL, a lot of uncertainties, right? How they will look like when they scale up. So this is, and so far they look like they are expensive. So cost is indeed another factor. And the last one I'd like to mention is the consideration of uncertainties. So we would like, so a robust design and management could, let's say, take place since, let's say, earliest stage of this conception of these value chains, because we are in a pretty much changing context, of course. I'm not saying anything new, of course, but there are a lot of uncertainties, not only endogenous to the process, because we are, let's say, under development, but also exogenous. So how legislation will change, how people perception will change, etc. So I believe also the understanding of, or a minimum understanding of all these uncertainties could also be critical. Yeah.
Thank you very much. You both made very concise presentation of the current situation. And yes, one point about enzyme stability and sensitivity is very sensitive, as if successful, we could perhaps make some processes that are like performing comparably to the thermochemical and catalytic ones, or even better than them, given the poisoning of catalysts and perhaps the greater robustness of enzymatic systems, or maybe in the case of wholesale biocatalysts. But there's so much uncertainty yet, and so many factors, both endogenous and exogenous, as Mar said. So we still need a lot of research and development. So, but once we face these research and development issues, we need to stick to the focus on the market and public perceptions and attitudes. So how would you think the consumer and the market perceptions and attitudes could be improved towards the biological CCU sourced chemicals? And would it make sense to develop and introduce different labeling and certification schemes than the ones already existing for catalytic and chemical CO2 based products and bio-based products? Or would we end up confusing the consumers and the end users even worse than we have already done? I think I would start with Joanna.
Yes, I think that the circumstances are extremely fruitful for implementing new mechanisms of social dialogue. Since the pandemic, where new, let's say, substances were introduced into human health, or the discussions about the climate crisis, climate sustainability, discussions on to a horizon for a greener Europe, etc. People have become very sensitive to everything. Any implantation, any investment, any innovation which might change the way they are thinking about things, they are consuming things, they are marketing things, etc. So I think what is very important, and the research has shown is to enter to a meaningful social dialogue. A social dialogue which would not be limited to the institutionalized consultation process in the preparation of bills or legislation, etc., but to a broader process that requires substantial exchange of views with all stakeholders at local, national, and big levels. Central to this process is to work together open channels of communication, and help find a holistic approach that satisfies local communities, specific audiences in which products are destined to, cooperation with environmental organizations and trade unions is also crucial, and securing information actions on financial resources is also essential to a success towards a just transition mechanism. Also, an important factor is in raising public awareness and assessing social impact of any innovative development or any implementation is to recruit the expert knowledge of the field. Because research has shown that local audiences they tend to trust more the experts than any governmental and non-governmental organization. So I'll stop here, and then later on we will probably discuss about which should be the most suitable communication campaign, which will accompany any innovation, any new product, any new implementation, establishment of a new industry, especially those which by the local communities are considered as a polluting the environment, etc. So I'll stop here for the moment.
Thank you very much, Joanna. Yes, actually the stakeholder engagement in all stages is crucial for the success of these technologies. And I'd like to ask Mar her opinion.
Yeah, so Despina and Joanna already, you pointed out the basic points, right? Which is indeed that major technological breakthrough will never be, even if it's perfect, will never be implemented if people or if the community does not accept it, right? So how we can overcome this? So then, of course, one big pillar is education. So I would say, I believe, the newer generations will be, and they are already more than us. So I feel that in the university they are much more conscious about climate change, of course. So they really know that they have to take action. So it has to be more and more in the future and upcoming generations and in the whole population in general. So this will be a specific action, and not only education and consciousness about climate change, but also education on these new technologies, right? So educating experts, for instance, in biochemicals, CCU processes, in electrochemistry, and so on. So that's basic. Also, from the sense of, let's say, looking more at the, let's say, more market and government stakeholders. So I believe that since these are technologies which are at low level, so now we have an opportunity also to involve all these stakeholders in what it can be called an inclusive technology, innovation and proactive design. And since this early stage, let's say, development involved politics, involved, let's say, public sector and private sector stakeholders, and start this dialogue, right? So what could be done, let's say, to motivate this implementation, why they think these implementations are not interesting, or if they are, why, and so on. So this dialogue should be there, and this kind of continuous retrofitting, let's say, cycle should be there. So I'm not adding anything new, because it was already been pointed out that all this inclusion of the different actors should be already there since the beginning of the, let's say, of this technological advancement. And looking at these different labeling, certification, etc. So I believe that even though population will be more conscious about this, still the simpler the better, right? So if we go to the market and there is one label for bio-based products, another for CO2-based neutral products, and maybe other categories, maybe people maybe get overwhelmed, maybe not, but we kind of know, right? So I believe the simpler the better, that's for sure. I think a good example is recycling, right? Because because recycling may occupy a lot of space in our places, and still people is reluctant to have maybe this space, right? Occupy because maybe we don't have this space. So we have seen a bit this issue with, another type of example, right, with recycling, where if it gets too complex, people do not recycle. So I believe the same is with labels. So if we go to the supermarket and we have to spend, I don't know, a whole 5 minutes for each product we buy, we will not do this, right? So I believe we have to acknowledge the fact that these, let's say, products can be CO2 neutral or are environmentally friendly in some perspective or the other, but the message has to be simple. And I don't have, of course, a solution, but of course the idea is to keep the simplicity in mind. Yeah.
You're totally right. That's the golden rule. The simpler, the better.
Yep.
But we might need a little help from the marketing teams for that. So how about you, Bertis?
Yeah, I think we were quite lucky that we are still in a low TRL phase, so that there's still lots of time in order to find the right strategy. And I recall the lecture we had yesterday from Helene de Wever from the BioRecover project. They already started some market research related to especially these questions on how would the market react on products that are produced by the means that we are now looking at. And I think those studies are very valuable in order to see what would be the best strategy. And yeah, I agree with the other speakers as well that it should be as simple as possible. So there should not be a new label. There are already many labels on the market. When you want to have a label, try to fit in existing ones and not make it more complex and just keep it as simple as possible. So that would be I think the take-home lesson. Keep it as simple as possible.
Okay, thank you very much. So moving on to our next topic of discussion, I'd like to ask you all, which would be the most pressing need at the moment regarding the policy making and standardization measures in order to effectively boost the market uptake of CCU technologies, and perhaps what would be the difference in the case of biological CCU technologies, would either for better or for worse? So I think I would start with Mar.
Okay, thanks, Cristina. So this is a good question, and you said that he was like pressing it, right? And it's true that we are in a situation where maybe we don't have time to take, let's say, a long period of time to let's say, to prove that these technologies may contribute to these climate change mitigation actions, right? So then we have this pressing need, so things have to happen soon. And I believe the most pressing need is the implementation of pilot projects, of course. So we need pilot projects, and we need to, and as much of them as possible. So I believe there should be a mechanism to ease this implementation. So public investment, of course, is needed here. We need big consortia, so the idea is also, because we were also talking before about the stakeholders, right? Stakeholders involvement since the beginning, so I believe we need big consortiums with a lot of players involved, because CCU also involves a lot of players. And I would say that this public, let's say, role is there for this implementation of pilot-scale project, which may succeed or not. And in the short and medium term, it will be also need to investigate legal, economic, and political social factors that could eventually act as barrier and enablers of this technology. And let me explain what I mean with that. It's like, we know that we're in a transition phase, and we have a clear objective, which is 2050 be carbon neutral. And we have a lot of legislation, a lot of, let's say, ways of doing, which kind of still, of course, respond to a fossil fuel-based society. So I think we have to understand very well what are those rules, what are those frameworks, and try to understand what of those, let's say, framework rules or specific ways of doing are barriers or enablers of these new technologies, and act on this. So wrapping up, I would say we need also this profound understanding of the current behavior of society, of political sectors, and of market, of course, and try to also change this as we go in parallel, of course, with the technological innovation. More, let's say, specifically for biological CCU technologies, I would say that indeed, when we, let's say, CCU, as we said before, has different, let's say, possibilities of thermochemical, electrochemical, biological routes. So one solution, of course, will not fit all. So I believe also each one of the solutions will have, let's say, each one of the technologies will be more, let's say, optimum or more ideal for a specific context, a specific maybe geographic area, etc. So that's to point out that many fossil fuel and these big, let's say, economies of scale plant that we are used to, we were more used to this type of solutions, that one solution fits all, and we are kind of replicating the same solution everywhere. But I believe with CCU will be more specific, context specific, right? And we have to be also open to accept this, let's say, individualities for each context or each situation. So indeed, wrapping up a lot of, let's say, pressing needs, and in a nutshell, we have to be open, of course, for new, let's say, approaches. That would be a conclusion, yes.
Correct. Thank you very much. Yes, that's a lot of pressing needs and a little time, unfortunately. So
yes.
Perhaps Bertis might want to say a word?
Yeah, I have a few things to add to that. I agree fully with Mar on what she just mentioned, but I think one of the key issues in the technologies we are looking at and that will be needed is the use of genetically modified organisms. And if you look at public acceptance, we should certainly look at that issue because it's a key technology in what we are planning to do. And if we look at the Green Deal, we can't look the other way. We have to use genetically modified organisms in order to reach the goals we intend to use. And I think that there's lots of public awareness that has to be changed in that subject, in that issue, in order to get our novel products accepted in due time and to continue on this road. Within Europe, it's still quite difficult when you compare to other parts of the world. The United States, for example, it's already much more accepted to use those technologies and techniques to reach the goals. And to reach our goals, we certainly should focus on that as well. We should not forget that.
That's true. That's a major aspect, and it's a very sensitive aspect in the European Union.
Yeah.
We're looking forward that we can use the technology provided in order to change this for the better. How about you, Joanna?
Yeah, I think I agree with our colleagues. I would like to add a few thoughts and ideas. I think one of the most pressing problems is to communicate correctly how our initiatives, the innovations, fit within the EU targeted areas and in what respect, because funding is a prerequisite and a very important factor. For example, a new innovation, a new plant, a new technology should respond on the agenda of a smart Europe, how it fits with research and innovation actions, digital economy actions, as an is recruitment, how the new technological initiatives correspond to the vision for a sustainable Europe in terms of low carbon economy, environmental and climate action, and network infrastructures, and also how to respond to all initiatives about an inclusive Europe, labor market issues, social inclusion, and human capital parameters should be addressed, communicated broadly on how the innovation corresponds and responds to these initiatives in order to the project to have funding sustainability. Another issue which is very important, I agree, is the ethical issues, how to curb dogmatic views about the genetic modified technologies. Especially, I think the era is helping because the planet cannot feed us all, and by the use of only natural resources. So new messages have to be invented and communicated, and how biological and biochemical solutions are not what they used to be. They are not pollutions but solutions actually. And to this, if I may add some thoughts from the previous question, the information actions and the communication campaign should include the following: the tailoring of the message, communication to be designed for an individual in regions of interest based on information from the individuals in regions of interest. Targeting the message to audience segments. For example, research has shown that the subpopulations of women in certain areas or the subpopulations of the very young people are sensitive towards certain issues, more sensitive than other segments of the population. So, if we have a new product, we should target the message to specific audiences, using narratives, communications delivered in the form of a testimonial or education on the issue at hand, framing the message. Communication that contains the same messages in alternative ways. For example, what is gained or lost by taking an action or making a choice or investing in a new idea. So these are my thoughts on the question.
Thank you very much, Joanna. Yes, indeed. We must not forget that, we shouldn't get too technical because our focus is on human society development. Our focus is always on the individuals and the societies, not just on the technical solutions. So, how about you, Bertis?
Yeah, I have not so much to add to that. Communication is key also, again, on all aspects, as well as on the scientific technical part, as on the effects it can have on society. And that's quite often forgotten in projects like this. On the other hand, it's requested when you look at the EU projects, that there is always much attention to the communication part as well. But as a scientist, we are often just looking at results and obtaining results as efficient and as good as possible, and we forget the communication part. And that certainly should get sufficient attention in projects like this, and also in future projects following this one, which also is, thinking, quite important to look forward to see how we can proceed from where we are at this stage.
You're right, and actually this was a major change from the Horizon 2020 program to the Horizon Europe, where now they have a larger involvement of social factors and social institutions, society institutions. So you're right that this is a major focus from the policymakers as well.
Yep.
And now to my last topic for today's discussion. I want to discuss with you about which funding schemes and capacity building mechanisms could be more appropriate for accelerating the market uptake of biological CCU technologies in both national and EU level. I don't know if anyone would like to take the word, perhaps Bertis?
Yeah, I'm not 100% read in the new program, but what I know, we previously had the BBI program, which was focusing on the bio-based industries. That's now followed up by the CBE. I forgot exactly what it stands for, but possibly the C is for circular and the B is also bioeconomy or something like that. So I think that there will be calls in that specific part that should, as a follow-up for this project. And we certainly should look into that. But on the other hand, I think there's also a big role for the large industries to be involved. They are the ones who mainly, or at least for a major part, are responsible for the problems we are facing. And what I notice, and what's my feeling, is that they are now looking from above to see what happens, and when the TRL levels are developed far enough, then they jump in. But they should facilitate those research much sooner at much lower TRL stages, and also not depend on the European Union or national agencies to finance the research, but also be actively involved in making available research budgets to continue the lines we are already on at this moment, and which look very promising. But nevertheless, they do need a significant push to get where we ought to be in a couple of years, say 5 to 10 years. So the contribution of larger companies, as well as the different possibilities there are within the European Union framework, should be taken advantage of as much as possible. At least that's my opinion.
Certainly, and we also had an input from our colleagues, our partners in the project yesterday, from BBEPP, that they also have gathered some interest from the private sector. Yeah. Unfortunately, we don't have them here today to tell us some comments about it. But the truth is, with the low TRL, the risks are still very high, and they would need some support in de-risking these investments at this point. I don't know if Joanna wants to add something.
Yeah, I would like examining the full spectrum of initiatives and EU policies to the 2050s. I think that there is a great emphasis placed on bioeconomy. There are opportunities, funding opportunities for innovative technologies in the agricultural sector, because there is this strong initiative from Food to Fork, which provides opportunities for innovative biochemical products and technologies. Also, the two funds, the Next Generation EU Fund and the Just Transition Fund, they could be employed to provide more resources, especially in cases where old technologies should be substituted by new technologies, less polluting and serving the target of the climate balance by the 2050s. However, one should take in consideration that, let's take the example from the results social research has shown from all regions of Europe who are now in the phase of lignite out initiative. There are various dilemmas and conflict resolution processes which should be taken in consideration before any new innovative plantation takes place. Because, for example, in Greece, there is strong skepticism and a big dilemma if we move towards renewable forms of energy or we should protect better the tourism aspects of the area. There is another dilemma on how to reskill the already skilled energy transporters. There is a dilemma what to look first, the employment of new people or the protection of the environment. So there are some big issues, and in certain cases, especially private sector investments are met with great opposition. So these are some of the factors and the parameters which should be taken into consideration before launching any new investment scheme or plan. Thank you.
Thank you very much, Joanna. Indeed, we do have many tools at hand, and I'd like to also add a number of funding instruments available from Europe, from the European Union. I don't know if you've heard about the Life Clean Energy Transition Call, which was publicized a couple of days ago. For the 2022 call is about a €100 million budget, and with a 95% co-funding rate. And apart from the Life Fund, there are it's the EU Innovation Fund, both in small-scale and large-scale projects. And of course, the ACT and the RFCS dedicated calls for the industry transition. And especially the RFCS is the Research Fund for Coal and Steel, which is related to our subject here today. And apart from those, there's the European Innovation Council, which has launched 3 tools: the Pathfinder, which supports research teams to develop breakthrough technologies; the EIC Transition, which builds upon promising research results already existing to mature technologies; and the EIC Accelerator, which uses the EIC fund for individual startups and small companies to develop and scale up game-changing innovations. So this is all from my side for now. I don't know if there are any comments or questions from the audience.
Yes.
But I thought maybe a bit of controversial question. Okay, so you see that, or you say that there's a pressing need to have these new technologies. There's expectation from society, policy, to get something against climate change, and that there is innovation needed more or less now. And on the other side, I worry a bit about, saying that there's a lot of research needed, a lot of basic research is now very low TRL. So when I look at the timescales, I think somehow I have the impression it doesn't match. Do you see any risks that this may lead to some frustration on the policy level and industry level, that things that are needed now cannot be delivered?
Oh, I'm not sure if somebody from the panel wants to answer this.
Yeah, maybe I can add a few things about that. There's of course always the risk that things don't work out like you expect them to be. And like this particular project, yesterday we had some presentation from other similar projects as well. And there are many ways leading to Rome. And I think they should join also their forces together. And there still always will remain a risk that we can't bring what is expected from us. But by combining efforts and the know-how from the other projects, which were to a certain extent quite similar to the work what has been done in this one, I think that could make us much stronger and improve the chance of success. But to guarantee it, there will always be a frustration of lots of money that goes into research and that doesn't result in anything. But yeah, that's just something we have to deal with. If we don't do it, nothing happens. So we have to take that risk. That's my idea. Yeah.
That's true. I don't know if some of our ladies want to contribute something to this discussion. Maybe Mar?
Yes, I agree with that. So, I mean, there is this risk, right? So we have short time, and things have to happen fast. So I believe it's a matter of funding and collaboration, as was said. So I mean, the previous scheme maybe it was slower, but now it's a special circumstance and things have to happen fast. And allow me to put as example the COVID, the development of the vaccination. So there was this cooperation, there was also this international need, and maybe more or less funding in one country than others, etc. But there was, somehow there was the resource and the urgency there, right? And I think this has to happen as well for climate change mitigation. Yeah.
Yes, that's true. Thank you very much. COVID came to my mind as well. Yes. How about Joanna? Would you like to add something?
Yes. Coming from the field of social sciences, we are used to do research in constantly moving societies, because the societal milieu is constantly moving. And from the time we have embarked upon a research initiative, by the end of it, let's say in 3 years, a lot of things have changed. Policies, legislation, some very important events may have happened. Wars, terrorist attacks, weather phenomena, etc., which influence our expected results. But even when our own specific research initiative cannot produce the results we wanted or had anticipated in advance, the fact remains that there is a path where to go and what areas to leave behind. So in certain cases, of course, we employ this scenario, a C scenario, on what will happen if our original scenario cannot produce results. But even if we do not have results, this is a research evidence. It's an evidence-based result which might be of value for policymakers or for the knowledge of society in general.
You're completely right. Thank you very much, Joanna. And I don't know if we have any more questions.
Well, just to add a comment, I wanted to align very much with Bertis' comment before. We had some nice results also, but with the collaboration with the other projects, the related projects, sister projects, we've reached successful microbial cell factories, but also we have in our consortium, apart from this, we have a pilot running, so it's something that we need to join forces and see whether we can continue with the future opportunities and bring this technology and increase significantly the readiness. So I think this is a challenge that you but I think also personally I just send to this consortium and see whether we can bring something forward in the next years. So any other comments or questions? I've checked also the online. I think there's no comment. No? Exactly. Perfect. So
thank you all very much for joining us. And thank you for your contributions to the discussion. And to our next steps.
Thank you.
We're ready.
Thank you for the opportunity. A pleasure. Yes.
Thank you.
Thank you so much.
Thank you for coming, and also to our validation board to be here.
Bye-bye.
Thank you. Then, well, thank you, Despina, also for the nice, it's driving very nicely this session. And now it's time for Montse, our technical coordinator, to just wrap up a little bit and give us some conclusions. So here.
Thank you very much, Xavi. Thank you very much, everyone, to your contributions during this 1 day and a half in this final event of BIOCON. So I think that in order to conclude this this event. I only want to add something. Not something. During these days, we have seen the most interesting results from a scientific point of view that the project can bring to future. So we have been researching in methodologies to increase gases solubility, not only CO2. We hope that these technologies can also help to increase the solubility of other gases, hydrogen, for example. But also we have developed tools and create new strains, new microorganisms, new enzymes in order to perform. We have improved the microbial cell factories to produce valuable products from CO2. As we have mentioned, all these sessions, we are still a low TRL. A lot of work is still needed in order to make this process more robust, more stable, more efficient, just to be ready to scale up. Also, we have contributed from the downstream point of view. It's another step that is very important from a costly point of view. So we have been able to develop some processes that can solve or try to solve this challenge that when we are facing this kind of bioprocesses, which is the low concentration of the target molecules that we want to obtain. And also, as we have also mentioned, the building of this mobile pilot plant that it's a very valuable tool in order to validate the technologies, the microbial cell factories, the approaches that we are producing at lab scale using real gases. So I think that these are the mostly, maybe I'm forgetting something, but they are the most interesting results or that the Biocon process can bring to the science from a science point of view, and it's a starting point for next projects, of course. We have also the opportunity to share some thoughts of the industry, different kinds of industries, the ones that are providing, which are these CO2 providers, that we have the opportunity to see these days that they are interested in this kind of technologies. They are more or less looking for what the scientists are doing on that, and I think that they will be ready for test these technologies and investing for trying to scale up the processes and go further beyond this TRL 4-5 that we are almost there. But also we have the thoughts of the end users. We have the opportunity to talk with to see the methods of fit, for example, chemical industry with Arkema, but also fit food industries. This economic and sustainability balance that it's very difficult to achieve. So it's some thoughts that are interesting for us, for the scientific community to take into account in order to decide which are the most interesting products, which are the processes that we have to try to go further in order to be able to make this, to fill this gap between science and market needs. Something that was very repeated during these sessions is the risk. So we have the interest, from the company's point of view, I forget to mention these thoughts of the bio-based pilot plant yesterday, when they said that we have noticed a very big interest of biotech companies in this kind of technologies, because these companies are the ones that should provide the solutions and make the gap between the CO2 providers and also the end users of the bioproducts that we are producing for with this technology. So the interest of the industry is there, but of course there are a lot of risks. We are not only from a technological point of view, but also from cost and environmental and social point of view. So it's something that, some concepts that we have already heard a lot of these days is CAPEX, height inversion, safety legislation, how will change during these days, electricity, low carbon methodologies, hydrogen source. So we need to couple, not only, we need to make this joint or these collaborations, not only between the ones that more or less are focused on CCU, but also with other, these other research lines also for combining all these research lines in order to be able to go further and increase the TRL of the technologies we are talking about. Also, yeah. So it's more or less more research. We have a lot of work to done today, and also we have the opportunity yesterday to discuss with other colleagues from other projects some research lines for future hires. Also in the floor, for example, combining, we see examples of combining bio-CCU technologies with other electrochemical and so on. So we need to go in that direction. Also in new microorganisms, new metabolic routes, also microtrophic approaches. There are a lot of opportunities. So we have also, in the session we have just finished now this public and consumption, and some aspects that we have to work together with the science, which is the communication, the education, and the market, work on also in increasing market acceptance, because we are facing also some challenges here, not only for the technologies we are using, which is GMOs, for example, and other, because the society, as it has mentioned, it's a good moment because they are conscious, they have awareness about the sustainability and so on, but which is the price that we have to pay to achieve this. So it's something that we need to also work on that. And yeah, I think that the main conclusion here is that there are still a lot of work for all of us during next years. So I encourage you to continue working on these bio-CCU technologies. Thank you very much to all of you for being here, for being part of the Biocon project, and I hope that we will work together again. Also, thank you to the people that are following us online. So I think it's time to close this session, and I don't know if someone wants to add something that maybe I forgot, some new home message to take home. If not, thank you very much. I hope you have enjoyed this event, and I think that we have this afternoon a very interesting visit to the mobile pilot plan. So next. That's all from my side. Thank you very much.